Good morning, dear student. In today's lecture, we will discuss the second course of our syllabus, that is CHI 331, in which we discuss the section second, that is photochemistry and reactions of coordinated ligands. So, photochemistry and reactions of coordinated ligands. So, this section includes 3 chapters, some important reactions of inorganic chemistry which is we already discussed, and the another 2 chapter, that is photochemistry and reactions of coordinated ligands. So, in this lecture we will discuss the first chapter, that is photochemistry. So, let us see one by one what is photochemistry, what are the important points of this photochemistry. So, photochemistry. In this photochemistry, we will discuss the definition of photochemistry, then the laws of photochemistry, 2 laws of photochemistry, then what is quantum wheel, then the recapitulation of fluorescence and phosphorescence, and then we see the DD transition and charge transfer transition for the photochemical reactions. So, what is this photochemistry? Photochemistry is a branch of chemistry which deals with the study of a rate of reaction and mechanism of a reaction which takes place or which is carried out with the help of irradiation of light. So, photochemistry is a branch of chemistry which deals with the study of rate of particular reaction and mechanism of reaction which takes place due to the exposure of light radiation. So, the first important point of this photochemistry or photochemical reactions, that is the exposure, the reaction or mechanism, reaction and mechanism of any reaction by exposure of light radiation, by exposure of light radiation. So, photochemistry, reaction and mechanism of any reaction by the exposure of light radiation. So, the light radiation have a broad spectrum of radiation. So, starting from gamma rays, X-rays up to NMR. So, there is a broad range of this light radiation. Out of this broad spectrum of radiation, only UV, ultraviolet and visible radiation are used. UV visible radiation are used in this photochemistry. So, the reaction and the rate of the reaction and the mechanism of the reaction by the exposure of UV visible radiation we will discuss in this photochemistry. UV visible radiations are necessary for any photochemical reaction, for any chemical change. So, UV visible radiation, you know the wavelength for this UV visible radiation, it is in between 200 to 800 nanometer. So, it is from 200 to 800 nanometer. So, in other words, you can say it is in range between 2000 angstrom to 8000 angstrom. So, these are some important points regarding to the photochemical reactions. The reaction which takes place by the exposure of light radiation, especially the exposure of UV visible radiation. So, which is lie between 200 to 800 nanometer, that is 2000 to 8000 angstrom. So, let us see some more important characteristics of this photochemical reaction. So, the main important condition for this any photochemical reaction is that the requirement of light radiation, then generally the UV visible radiation is required for any photochemical reaction or any chemical change. Another important point of this photochemical reaction, it is there is no effect of temperature on this photochemical reaction. So another important feature is that no effect of temperature on photochemical reaction. So no effect of temperature on photochemical reaction. So if we see the difference between photochemical and thermal reaction, in thermal reaction the temperature is a necessary conditions. So in photochemical reaction there is no effect of temperature on photochemical reaction. Another important characteristics of this photochemical reaction is that the energy of activation is achieved. The energy of activation is achieved by absorption of light radiation. So energy of activation is achieved. Energy of activation is achieved by the absorption of light radiation, generally UV visible radiation. So energy of activation we will discuss in our previous lecture, that is the minimum energy which is required to convert the reactant into the product is nothing but the energy of activation, and whatever the energy of activation which is required to convert any chemical change, to convert any reactant into the product is acquired in this photochemical reaction by absorption of light radiation. So this is also the important feature or important characteristics of photochemical reactions. So energy of activation is achieved by the absorption of light radiation. Another important feature of this photochemical reaction is that the energy change may be positive or negative. Energy change may be positive or negative. So in other words we can say that the Gibbs free energy, that is delta G, may be positive or negative. Either heat is gain or heat is evolve. Okay, so energy is gain or energy is evolve, that is delta G is positive or delta G is negative. So if you consider the thermal reaction, in thermal reaction the heat is evolved, therefore delta G is always negative. Delta G is always negative for thermal reaction, but in this photochemical reaction delta G may be positive, may be negative. So energy change may be positive or negative. Another important characteristics of this photochemical reaction is that it is highly selective. It is highly selective. So what is the meaning of this highly selective? So photochemical reaction is highly selective means the energy which is absorbed by a particular molecule. So if you consider a one quanta of energy is absorbed by a single molecule, then the molecule is excited, electronically excited, and it is goes from ground state to the excited state. If there is 100 molecule and only one molecule is absorbed, one quanta of radiation, then only one molecule is electronically excited. Not all the molecules are electronically excited by the absorption of light radiation. Therefore, these photochemical reactions are highly selective. If you consider a thermal reaction, if you increases the temperature, the rate of reaction is also increases and the energy of all the molecule is rises. The energy of all the molecule is increases. But in this case, by absorption of light radiation, only a particular molecule which absorb a light radiations are electronically excited and other molecule do not activated by the absorption of light radiation. Therefore, this photochemical reaction is highly selective. So another important condition or important characteristics of these photochemical reactions. These photochemical reactions are of two types. One is photophysical and second is photochemical reaction. So photophysical and photochemical. So what is the meaning? What is the difference between this photochemical and photophysical reaction? In photophysical reaction, the light radiation is absorbed by the molecule, but there is no any change. There is no any change. Okay, so this is called photophysical reaction, while in photochemical reaction, by absorption of light radiation there is a chemical change. Chemical changes occur. It is called photochemical reactions. So these are the important characteristics of photochemical reactions. So photochemical reactions are, or photochemistry is a branch of chemistry which deals with the study of the rate of the reaction and mechanism of the reaction which takes place by the absorption of light radiation, generally UV visible radiation. So let us see some laws of this photochemistry. Next important point is that the laws of photochemistry. Laws of photochemistry. So in photochemical reaction or in photochemistry there is a two laws of photochemistry. The first law, that is Grothus-Draper law. The first law is Grothus-Draper law and the second law is Stark-Einstein law. So let us discuss what is this Grothus-Draper law. This Grothus-Draper law, it gives, or it is a physical, it is in physical in nature. It is in physical in nature, or in other words we can say that it is qualitative in nature, not physical. It is qualitative in nature. So what is the meaning of this qualitative? It is qualitative in nature. So let us discuss the statement which is given by this Grothus-Draper law. So by the absorption of radiation, that is generally absorption of UV visible radiation, the molecules get activated and the activated molecules are convert, or activated molecule shows certain changes, that is chemical changes. So if we consider, not all the radiations are absorbed by the molecule or a system. So a incident light is, if we strike the incident photon on particular system or molecules, some light get reflect, some light get transmit and some light get absorbed. So only those radiation which is absorbed by the molecules are responsible for any chemical change, and this is the statement for this Grothus-Draper law. So any chemical change which is occur, any chemical change which is occur due to the absorption of radiation, the radiation which is absorbed only results into chemical change. So the main important point of this Grothus-Draper law is that only absorbed radiation results into the formation of chemical change. So not all the radiations are absorbed by the molecule, by the system. So only those radiations are absorbed are results into the chemical change. If we consider I0 is the intensity of incident radiation, intensity of incident light. Then if you consider IA, that is the intensity of absorb light or absorb radiation, and IT, that is the intensity of transmitted light, intensity of a transmitted light. Then we can write I0 which is equal to IA plus IT, that is the radiation which strikes on particular system which is equal to the absorbed radiation plus transmitted radiation. From this equation we can write the intensity of absorbed radiation which is equal to I0 minus IT. So with the help of this equation, if you know the intensity of incident radiation and if you know the intensity of transmitted radiation, then we can find out the intensity of absorbed radiation. So according to the Grathus-Dropper law, not all the radiations are absorbed by the molecule, by the systems. So the only radiation which is absorbed or results into the chemical change. If you consider I0 is the intensity of incident light, IA is the intensity of absorbed light, IT is the intensity of transmitted light, then IA, that is intensity of absorbed light, which is equal to I0 minus IT. So this is regarding to the Grathus-Dropper law. It is qualitative in nature. So this statement which is given by Grathus-Dropper law, it is qualitative in nature. So it does not give the information regarding to the how much energy or how much quanta is absorbed by the molecule or by the system, and how much and how many molecules are activated by the absorption of these radiations. So it is just qualitative, it gives just qualitative information that only absorbed radiations are responsible for any chemical change. Not all radiations are responsible for chemical change. It is qualitative in nature because it does not give information regarding to the how much quanta of radiation is absorbed and number of molecules are activated and converted into the product. So this is regarding to the Grathus-Dropper law. Another important law in this photochemistry, that is the Stark-Einstein law. Second is Stark-Einstein law. So this is also an important law, that is Stark-Einstein law. So according to this Stark-Einstein's law, it gives a quantitative information. So first important point is it gives quantitative information. It gives quantitative information regarding to photochemical reaction. So according to the Stark-Einstein law, if one molecule is present, it will absorb 1 quanta of radiation. If 10 molecule is present, it will absorb 10 quanta of radiation. If 100 molecule is present, then it will absorb 100 quanta of radiation. So what is the statement or what is the conclusion of this Stark-Einstein photochemical law is that the number of quanta which is absorbed, so 1 molecule absorb 1 quanta of radiation, 10 molecule absorb 10 quanta of radiation. So individual molecule absorb 1 quanta of radiation. So we can write here 1 molecule absorb, according to this Stark-Einstein law, 1 molecule is absorb 1 quanta of radiation. 1 quanta of radiation. So if you consider 1 quanta of radiation or energy, 1 quanta of radiation, that is nothing but the energy which is equal to h mu. Energy, or it is also known as quanta. 1 quanta of radiation, energy which is equal to h mu, where h stands for Planck's constant and mu is your frequency of radiation. So energy which is equal to h mu. So this is considered as 1 quanta. If 1 molecule is present, it will absorb 1 quanta of radiation, that is E is equal to h mu. If 10 molecule is present, it will absorb 10 quanta. For 1 mole of any molecule or any system for 1 mole of a molecule. So 1 mole of any molecule is for, if you consider 1 mole of any molecule, 1 mole of any molecule contain 6.023 into 10 raised to power 23 molecules. That is 1 mole of any substance contain the Avogadro's number. So number of molecules, if you consider for 1 mole of a substance, 1 mole of a substance, so instead of substance, 1 mole of a system or 1 mole of a molecule, 1 mole contain 6.023 into 10 raised to power 23 molecules. That is nothing but your Avogadro's number. For single molecule, we require 1 quanta of energy. For 1 mole, that is Avogadro's number, the number of quanta or energy which is required is equal to E, which is equal to N0 H mu, N0 H mu, where N0 is nothing but your Avogadro's number. So this is for 1 mole. So 1 mole is nothing but the number of molecules which is equal to this Avogadro's numbers. So for 1 molecule, energy which is equal to H mu, and for 1 mole of any system or any molecule, energy or the quanta of radiation which is equal to N0 H mu, where N0 is your Avogadro's number, H is your Planck's constant, and this is mu is your frequency. So we know that frequency which is equal to C upon lambda, that is velocity of light and wavelength divided by wavelength. Therefore the quanta or energy which is equal to N0 H C upon lambda. So this is the equation for 1 mole of any molecules. So energy which is equal to N0 Hc upon lambda. From this equation, this energy and this wavelength are inversely proportional. Energy and wavelength are inversely proportional. So this is regarding to the second law of photochemical reaction or photochemistry, that is Stark-Einstein law. According to Stark-Einstein law, 1 molecule absorbs 1 quanta of radiation. So 1 mole of any system or molecule absorb N0 Hc upon lambda quanta of radiation. And this is regarding to the laws of photochemistry. So we will discuss some important points regarding to the photochemical reaction, and we will discuss the 2 points of photochemistry, that is, first is Grothus-Draper law and second is Stark-Einstein law. So according to the Grothus-Draper law, not all the radiations are responsible for the chemical change, only the radiation which is absorbed are responsible for chemical change. And according to the Stark-Einstein law, so 1 molecule, if it is present, it will absorb 1 quanta of radiation. Therefore for 1 mole of any substance or molecules or system, then the quanta which is absorbed, which is equal to, or energy which is equal to N0 H mu, that is 1 mole which is equal to Avogadro's number. Therefore the quanta which is equal to, energy which is equal to N0 H mu. This is regarding to the second law of Stark-Einstein law. In next lecture we will discuss the quantum yield and the related phenomenon such as fluorescence and phosphorescence. Thank you.